In this video, we'll learn how to save our key bindings using the old Unity input system and implement our mouse settings. As the name suggests, key bindings are the keys needed to perform a certain action. When someone wants the action to be binded to a different key, they would need to access the settings and change it accordingly. If you're using the new input system, I highly recommend checking out this video by One Wheel Studio. He does a fantastic job explaining how to rebind your keys using the new input system. For now, we'll use the old input system to coincide with our current character controller. First, we'll need a player to control, so we'll export our character controller and import it into our current project. If you don't have this, you can use your own character controller, or you can follow our character controller tutorial and import it when you're done. To export the character controller, I created a folder called character controller, put everything inside this directory, and exported the folder. Before we drag this into our settings project, rename the scene assets to settings scene as well as the related profiles. This is because some of the assets used inside our character controller are named similarly. It would overwrite these files, which we do not want. Once imported, we'll need to take the imported comp player inputs code and paste it to our current comp player input script. After doing this, delete the imported comp player inputs and we'll solve various errors by using the correct namespaces, tbob. Drag the character controller scene into our hierarchy and ensure that the player has the new comp player input script. Drag that player into our settings scene, assign the camera to the camera controller, and add the initialized scriptable object GO script to the player. Assign the keys, and our escape menu cannot be clicked. This is because of how we manage the cursor when using the character controller. To fix this, we'll change some things in the escape manager. When we open the escape menu, we'll pause the game by using timescale, make our cursor visible, and unlock our cursor. This way, the player can choose things properly when we open the menu. We'll do the complete opposite for when we close the escape menu. We'll also change the close menu function into a public function because the resume button lacked the proper functionality for resuming our game. Assign the escape manager to the escape menu, and if everything was done right, you'll have the player walking around the scene and the escape menu should be working properly. You'll notice that the slider saves our settings file on click up. This was an oversight and we do not want this, so just delete it under the receive slider value function. Now, we're going to make a scriptable object that can be referenced anywhere and use that to manage our inputs. Here, we'll copy over the inputs and make sure we're using the tbob input rather than the one provided by Unity. You can make this cleaner by enclosing this around the tbob namespace, but I just did it this way anyway. Make sure you're using the create asset menu attribute, and once finished, create the scriptable object and reassign the inputs. Inside comp player inputs, delete the old inputs and add a reference to this new scriptable object. We'll change the code to reference their appropriate input values. Inside Comp Escape Manager, remove the player input component reference and just use the scriptable object instead. Under Comp Character Controller, reference the sprint input from our scriptable object. Assign the scriptable object to Comp Player Inputs and the Escape Manager. Once finished, the inputs should work exactly the same, except now it uses the scriptable object instead. Let's set up our game settings menu. We'll make a script called comp game settings and add several variables. We'll have the settings, the player inputs, and a new class called KeyBindBundle. This class will help us change the button properties such as text when we change our keys. Now, let's create our keybind pop-up. It'll be similar to pop-up to timer, so we'll duplicate it, unpack it completely, and change some things. It'll essentially just be two texts where one tells us what key we're changing and the other tells us what the key is currently bound to. drag this into the prefab folder when finished. Once that's done, add a settings drop-down game object to the game settings menu. Again, unpack this, but this time we'll change the drop-down to a button. If you're using the new TMP button, you'll need to import the TMP Essentials. This will pop up the moment you use anything TMP related. Import it and ensure you can see the button, label, and button text. Make it as generic as possible and drag this into the prefab folder when finished. Now, let's duplicate this for all the keys that we're using. In this case, we have 5 keybinds: forward, backward, left, right, and sprint. Rename each prefab to their appropriate settings. This includes the parent object, the button object, the label object, and the text for that button. Under the game settings component, add all of these keybinds and references to their appropriate keybind bundle. Each bundle needs the key name, which is key sensitive and should be the same throughout, the key button, and the button text. Next, we'll need a reference to the keybind pop-up and the 2 texts. With all that prepared, we can get to coding our script. We'll start with the initialize function. This function will ensure that various variables go back to their default state. Wait for key will be used when we request a keybind, so we need to turn this off when we first enter. The pop-up should also be off too when we enter. We'll also need a list of accepted keys, and we'll use that when we get our player input. Now before we can set the keys, we'll need to know what keys we're setting. This will be based on whatever keys they saved, so we'll tackle saving first. Inside settings file, we'll create several variables, one of which uses another serializable class called Keybindings. All the contents must be primitive to be saved, so we'll make a string called keyname and an integer called keycode. Ensure the generic namespace is added. While we're here, we'll also add a float for mouse sensitivity and 2 bools for the vertical and horizontal inversion. I'm also pretty sure the settings file data function was redundant, so we'll remove that. I was initially going to assign the variables in the settings file each time we wanted to save. However, we can just reference the settings file class using our scriptable object, update the desired value, and just call save data to disk. There's no need to reassign everything. Inside the comp player inputs, ensure that you add a string called keycode for the input class. This will help distinguish the input based on a string. Then, under the default scriptable object, add in the new variables that we added for our settings file script. Remember to import the necessary namespaces. Inside SO settings, we'll make sure we update the settings file with the correct values predetermined by our default scriptable object. Since this function implies this is the first time we're running the game, we'll sift through all the key bundles in our default scriptable object, create a new bundle for each of them, and add it to our settings file. Inside our default scriptable object, add the key bindings that the user will have on load. To save you time, I found the keybind codes using debug logs. Whenever we start a fresh game or lost our settings file somehow, we will use these key bindings to play with. Now we can actually set the key bindings. When we start the game settings, we'll update the UI to reflect the keys found in our scriptable object. If the key name in the scriptable object matches the key name in our UI key bundle, then we will call a function called setKey. In this function, we'll simply just update the values in our UI key bundle and display the appropriate text alongside it. Back in the editor, assign the pop-up, run the game, and it's not working. Make sure you also update SO player inputs to have the correct names, and it's still not working. That's because we have an old settings file that did not have our new key binding code. Delete that and try again. Now it should work. Check the settings scriptable object, and you'll see the default scriptable object successfully transferred the data, and the UI elements now display the correct information. Now, let's tackle the pop-up. We'll first need to assign events to each button. We'll iterate through all the key bundles, and for each of their buttons, we'll call a function called popUpHandler and pass in the corresponding keybind bundle. Inside popUpHandler, we'll replace the 2 texts in our pop-up with some strings that include the keybind's name and the key that's currently bound to the input. We'll turn the pop-up on, assign our current key as the key that's passed in, and we'll start our update check. When wait for key is true, it means the pop-up is currently open. We'll iterate through all the accepted key values, and if the user enters an accepted key, we'll check if they hit escape. If they hit escape, we'll simply stop the update condition and close the menu. Otherwise, we'll start initiating our key rebinding. We'll pass in the key that we pressed and the current key that we're currently replacing. Inside Set New Key, we'll make a new list of inputs that includes all the inputs found in our player inputs. This is mainly to help us iterate through specific conditions. Let's start with removing any duplicate keys. We'll go through each of the player's inputs. If any of the keys match the new key that we entered, we'll find the appropriate UI element corresponding to the duplicate key. That key will be overwritten with a new key code value of none, and the UI element will be updated to say none. We'll then find that key inside our settings file and update the value so that the duplicate key would be saved as none too. We'll then change the player input key to be none and break. Now to add the new key. Again, we'll look through all the player's inputs, and if the current key matches the key name of our input, then we'll update the key's primary key to the passed in new key. We also need to iterate through the save settings key bindings and update that too. Afterwards, we'll ensure the UI key bindings are updated and close the pop-up menu. Lastly, we'll enter our comp load manager script and add our game settings to be initialized on loadup. We'll make a variable for our player input scriptable object and make a new function called game settings. In here, we'll apply the saved key bindings to our player inputs so that any key bind changes will reflect the character immediately on load. Now we can test. You can see the save settings scriptable object change its values as you change each key bind. When you re-enter the game, the settings should remain the same, and if you delete the settings file, emulating a new game, all the default settings are copied over. You can also see the changes reflected in player inputs. So let's say you wanted to add another key bind. You would need to follow these steps. First, player inputs must be updated to include the new input. Second, the default settings scriptable object must include a new key bundle. Third, the UI bundles under game settings must include the new key. Fourth, you must add the new key under the game settings function. And finally, you must add the input to the list inside set new keys. Now, let's add mouse sensitivity and inversion to the menu. We have our prefabs prepared, so just add one slider and two toggles to the menu. Make sure you rename the toggles, labels, sliders, and text helpers for each new setting. Let's start with scripting. We'll need a reference to our sliders and toggles. Remember, slider settings is a class found under our slider script. This was used for our other sliders. From our video settings script, you can copy over the receive slider and slider changed functions. Here, we'll modify both of these functions to use the mouse sensitivity slider. Make a constant string for the slider and use that to differentiate between sliders that are being passed in. Now, I've already explained how this works, but just as a refresher. Whenever the slider moves, the slider changed function will be called constantly. In this case, all we do is convert the virtual value to the actual value in order to update our text. Usually, we use this to change the setting in real time, but mouse sensitivity can only be tested outside the pause menu. Therefore, we just use this function to update the virtual text counter. Once they release the slider, the receive slider value event will be raised, and will update the mouse sensitivity inside the settings scriptable object immediately. Attach the slider counter, and we've determined that the mouse sensitivity should be between an actual value of 0.1 and 10. Inside our camera controller, we'll delete the mouse sensitivity, add the settings scriptable object, and make the mouse sensitivity depend on the value found on our settings scriptable object. Attach the settings scriptable object and set the default mouse sensitivity value to 3. Lastly, attach the onValueChanged event to the slider itself, calling the sliderChanged function, and ensure that you set the slider value based on the actual to virtual conversion function. Now when you test, you can see the value updating in our scriptable object, and the mouse sensitivity changes accordingly. Now for the last part, toggles. We'll add an onValueChanged event to the toggles and call a function called toggleInversion. We pass in the toggle itself, differentiate between the two toggles, and turn them on or off depending on the situation. On initialization, we'll set the toggles based on the settings data without sending a notification. Inside Camera Controller, set the inversions to take on the settings scriptable object and change it accordingly. Note that our vertical inversion is on by default. This is just from how we coded our camera controller. Once you have that complete, you can test. Now, when you turn either of these bools on or off, it will invert itself accordingly. Make sure the scriptable object is properly saving, and with that, our game settings are finished. We're finally done with Keybindings. The concept is fairly easy once you get the hang of it. I haven't really tested this outside of a keyboard and mouse, so you may have to fiddle around with the code to accommodate controllers and such. The new input system works well with this too, so be sure to look into that. The next settings video will probably encapsulate the audio and interface settings. Anyway, I'll see you next time.